Hello everyone, welcome to Mobile Class Academy. This is where we make learning fun and we bring it to the doorstep of wherever you are. We don't make learning fun alone, but we make it impactful and informative so that you can be a better student. My name is Taiwo and I'll be your math teacher. This is the day 3 of our back to school preparation classes. The summer period is over, so students are going back to school. So we are doing this to prepare students for resumption. This is day 3 of our program, and in case you've mixed day 1 and day 2, what day 1 is all about is the introduction to quadratic equation. Quadratic equation, when the value of a is 1 or when the coefficient of x squared is 1, how do we solve that kind of question, or how do we resolve that? So that's what day 1 is all about, and we use different scenarios to justify that. Remember, we are still under factorization method. If you attend day 1, you will understand what I'm trying to say. So if you've mixed day 1 is available on our platform, Mobile Class Academy, on YouTube and on Facebook. So day 2, we discuss when the value of a is greater than 1. So we'll walk through different scenarios and examples, and we make sure that no stone was left unturned in applying that formula to solve quadratic equation. Now this is day 3 and we are looking at difference of 2 square and perfect square. What do we mean by difference of 2 square? We are going to explain this in details, but firstly, what is a square? In mathematics, if you are given square, we write it in this form, a square. And what does this mean? It means a times a. This a we're looking at standalone is not really standing alone. It has a power of 1 and a power of 1. But in mathematics, we don't normally write 1, especially if 1 is multiplying a value. So we don't write that 1. But if the value is 2, 3 upward, we do write it. Now, if we do a times a, what does this mean? It means a, the power of first a, this one, is 1. The power of the second a, which is this one, is 1. So all we do is we add. And when we do that, we have a raised to the power of 2. So a times a equals to a raised to the power of 2. Any value can be a squared. We can have 3 squared. We can have b squared. We can have p squared. We can have different form of squares. But our attention today is how do we solve problems of difference of 2 square and perfect squares. If I write out 1, 4, 9, 16, 36, 49, 64, 81, 100, all these numbers you can see here, they have something in common. They have one thing in common. And what they have in common is what makes them unique. Look at 4. 2 raised to the power of 2 is going to give me 4. If I do 3 raised to the power of 2, is going to give me 9. If I do 4 raised to the power of 2, is going to give me 16. If I do 6 raised to the power of 2, is going to give me what? 36. If I do 5 raised to the power of 2, is going to give me 25. If I do 7 raised to the power of 2, is going to give me 49. If I do 8 raised to the power of 2, is going to give me 64. 9 raised to the power of 2 is going to give me 81. 10 raised to the power of 2 is going to give me 100. All these numbers that I've listed are called what? Perfect square. Perfect square. Why are they referred to as perfect square? They were referred to perfect square because if we take their square roots, they are going to return a whole number. Look at 4. 4 is the same thing as 2 raised to the power of 2. This power of 2, we cancel out this square root, is going to give me 2. Now, let me explain what the square root means. This square root means the power of half. Square root of 4 means 4 raised to the power of half. And this same 4 means 2 raised to the power of 2 times half. So 2 goes here, 1, 2 goes here, 1. So square root of 4 will give me what? 2. Now let's do for 9. 9 is here, right? 3 raised to the power of 2 is 9, right? Now, let me put this in a square root. It's going to give me 3 over 2 times half, power of half. 2 goes here, 1, 2 goes here, 1. So I'm left with 3. So square root of 9 is what? Is 3. Any number that when put in a square root returns a whole number without a remainder is what? Is a perfect square. Now, if I have 8 and I'm looking for square root of 8, square root of 8, what will that give me? It's going to give me product of 8, 4, and 2, right? If I do square root of 4 multiplied by square root of 2, it's going to give me 2 and square root of 2. This square root that we can resolve is a remainder. Therefore, 8 is not a perfect square. 8 is not a perfect square. So what I'm trying to explain is this. Any value that when you put in a square root and return a whole number or a whole value is a perfect square. If I do 81, it's the same thing as 9 squared. And the same thing as 9 squared times half. 2 goes here, 1. 2 goes here, 1. So square root of 81 is what? Is 9. So this is the answer. But let me do for 8. 8 is the same thing as 4 times 2, which is square root of 4 times square root of 2. This is 2, but this one cannot be any value that can be squared. We cannot resolve this. So this one is a remainder. Therefore, 8 is not a perfect square. 81 is a perfect square. Hope this explanation is informative. Now, how do we solve difference of two squares? Under difference of two squares, each value has a squared attached to it. Each value has a squared attached to it. Look at this. A squared minus b squared. This is a perfect example of difference of two squares. We can see that a bs is square, b bs is square. In mathematics, difference and minus are used interchangeably. Difference and minus are used interchangeably. So if we look at this, we have difference of 2 squared. That means a squared minus b squared. That's what it means. Difference of 2 squared. So if we have this kind of square and we want to resolve it, how do we resolve it? The formula for resolving it is a minus b in brackets a plus b. This is the formula we use in solving it. Now, look at this. Let's resolve this with this formula. If I do that, I have a times a is what? A squared, right? A times plus b is ab, right? Minus b times a is minus ab. Minus b times plus b is going to give me minus b squared. Minus times plus is minus. So minus b times plus b is going to give me minus b squared. When we look at this, plus ab minus ab, this will cancel out. And I'm left with what? A squared minus b squared. When you look at what I have here and what I have here, you'll see that it's the same thing, right? The best way to resolve difference of two squares is to open two brackets, put the first value and the second value. This is the first value, second value, first value, second value. Open two brackets, put the first value and the second value in them, then introduce negative and positive sign. So what I'm saying is, when you have a squared minus b squared, open a bracket, do a minus b in one bracket, a plus b in another bracket. So when you expand that, you will still come back to what you have here. You come back to what you have here. Now let's resolve perfect square. How do we handle perfect square? When we're talking about perfect square, each of them don't bear their square individually. This is what I mean. A plus b, bracket a plus b squared, their square will be outside. Their square will be outside. If we have a minus b, bracket a minus b squared, the square will be outside. The expansion of this and this is different from the expansion of a squared minus b squared. the expansion of this one is different from these two. So how do we solve these two? If you are solving perfect square, what you need to know is the formula for this, for positive, is we have the first term, we have the second term. So this is the formula for solving perfect square. You are to square your first term, which is a. So you are to square your a. Then, because we have a plus sign here, you do plus twice the product of first term and second term. Twice means 2. The product of a and b is what? AB. Then plus the square of your second term, which is b square, right? Now, if we are doing for this, this one is positive sign. So we have positive all through. We have positive all through. Now we have negative here. How do we resolve that? The same approach. We are to square. This is the first term. This is the second term. So we square the first term, just like we did up. Because we have a negative sign here, we put minus. Are you with me? Now, what is the next thing? Twice the product of AB. Twice means 2 the product of AB, which is what? AB. Then we have a plus second term squared, which is b squared. Let me take it again. If we are expanding perfect square, the approach is square your first term, which is a, and that's what we did here. Because of the negative sign, you introduce negative sign here. Then you do twice the product of your first term and the second term. And the product of first term and second term is a times b. Twice your products. Twice the product of first term and second term. That is twice 2. Product of a and b is ab, right? Then square your second term, which is b. Minus times minus is going to give what? Positive. And that's how we arrive at positive here. So it's going to be positive b squared. Now, let me explain this again. I have my first term, second term. I square my first term, a squared here. Then twice the product of first term and second term. That's what gives me 2ab. Then square of my second term. That's this. Now we have the understanding of that. So we can go to our questions or our examples. We can start solving our examples. So this is the foundation for solving difference of 2 squared and perfect squares. Example 1. It says factorize x squared minus 36. X squared minus 36. Now, how do we solve that? Solution. Look at this question. Is it a perfect square or different of 2 square? X squared minus 36. Is it a perfect square or different of 2 square? Let me help you to present it better. Maybe you will understand. We have x squared minus 36. What is 36? 36 means 6 raised to power of 2. Right? 6 raised to power of 2. Now, let's rewrite it. X squared minus 6 raised to power of 2. So at this point, I'm asking again, is this perfect square or different of 2 square? Perfect square, the square is always outside. But here, this is individual value carrying their square. So this is different of 2 square. Remember how we used to solve different of 2 square, which is a minus b, a plus b. So how are we going to solve this? We open 2 brackets. We put one a and another a, right? In this case, let's put x in one and put the second x in the second. Then, this is 6 twice. So we put our 6 here, then we put our 6 here. What do we do next? We introduce different signs, minus, plus. So this is how to solve it. So this will be the answer to this equation. And if you want us to check it out to know if we are right, we can. Let's do x times x is going to give us x squared. X times plus 6 is going to give me what? Plus 6x, right? Minus 6x times s, this is minus 6x. Minus 6 times plus 6 is going to give me what? It's going to give me minus 36. Plus 6x minus 6x, we cancel out. We are left with what? X squared minus 36. If we look at what we're given in the question up here and what we have here, you see that is what is the same. Is that understood? Now, I want to show us another style. Of solving this problem. You know, we have our quadratic equation to be of this format: ax squared plus bx plus c. If we look at this equation, we have our x squared, right? We have our as squared, then we have our constant, which is c, but we don't have this. Now, let's rewrite this in a quadratic equation. We have x squared plus, because we don't have our bx, so what are we going to use to replace the b? 0 minus 36. And you know, in the previous classes, while we're doing factorization of a equals 1, we did mention that what are the two values that when added will give us 0. Remember, when multiply will give us minus 36. When we multiply, it's going to give us minus 36, but when we add, it's going to give us 0. So what are the two values of 36? We know that 6 times 6 is 36. What can we do to give us 0? If we do minus 6 plus 6, if we replace 0 with minus 6 plus 6, is going to be x squared plus 6x minus 6x minus 36. We group what's common? X, right? X plus 6. If we take out our minus 6, what do we have here? We have minus 6x plus 6. Minus 6 times x will give me minus 6x, right? It will give me minus 6x. Minus 6 times plus 6 will give me minus 36. So what we have here is correct. Now, if we group what is outside the brackets, we have x minus 6, right? Then we have x plus 6, right? So factorization of this will give us what? Will give us what we have here. Are you with me? And when you compare what we have here with what is here, is it the same or not? Is it not the same? So we can use this formula and we can use this formula. But I believe this formula here is time saving. It saves us time than this formula. So whichever one we find suitable, we can use. We can decide to use this one and we can decide to use this one. But for the purpose of this class, I will stick to the one here. I will stick to what? To the one we have here. But you know, if you work it using this style, you will have the same results. Now let's go to example 2. Example 2 is like the former one. Example 2, it says factorize s squared minus 100. You know, this is similar to what we did earlier. So solution, x squared minus 100 is the same thing as x squared minus 10 squared. Because they are different of 2 square, we are going to do our two brackets. We put one x here, we put another x here. Then the 10, we put the 10. You know, the 10 is 2. You understand? The 10 is 2. We put one in the first bracket and we put the second one in the other bracket. Then we introduce our different signs. So this is the answer to the question. I hope this is clear. Now let's look at something a bit different from this regular one. Now example 3. Example 3, factorize. Factorize what? Factorize 2x squared minus 50y squared. Do you want to give it a try? Before we solve this question, do you want to give it a try where you are? Do you know what to do? Okay, let me solve this one then. Example 4, you might want to give it a try. Let me quickly solve this one. When you look at this, we can't factorize because we have x squared, y squared here, right? But when you look at 50, 50 is not a square of any number. 2 is not a square of any number. So how do we get square for these two values? We have to divide this equation by 2. Do you understand? Or let's say, what's common between this and this? So we know 2 is a common factor. So if we divide through by 2, we keep 2 outside. 2 is a common factor. So let's take 2 outside. So 2 goes here 1. 2 goes here, 1. 2 goes here, 1. 2 goes in 50, 25, right? Now, the 2 we used to divide it, we put it outside. Then we have x squared minus 25y squared. If we want to expand this bracket, it's still going to give us what we have here. 2 times x squared is going to give us 2x squared, right? Minus 25 times 2 is going to give us minus 50y squared, just as what we have here. Let's continue using this to solve our problem. Let's break everything in this bracket down a little. We have 2 outside, x squared minus 5 is a square of 25, right? So we have 5 squared and we have y squared, right? Are you with me? So from here, what are we going to do? Let me explain this equation to us. From here now, we have 2x, 2 5s, 2 y's. So how are we going to solve it? Let's open our bracket, the 2 brackets. We have 2x here. Let's put 1x here and 1x here. We are done with the x side, right? Now we have 2 5s. Let's put 1 5 here and another 5 here. We are done with the 5 side, right? Now we have 2y. Let's put 1y here and 1y here. Do you understand? So 5y times 5y will give us what? 25y squared. So at this point, what are we going to introduce? Our sign. If one side is negative, the other side will be what? Positive. Then remember, we still have our 2 outside. So the answer to this is going to be what? X minus 5y bracket x plus 5y. So this will be the answer to this question. This will be the answer to this question. So if we understand the step-by-step approach, it's going to be very easy to solve this type of question. Now let's look at example 4. What is our example 4? 2p squared minus 8 bracket p plus q squared. Are you with me? 2p squared minus 8 into bracket p plus q squared. 8 bracket p plus q squared. So how do we solve this problem? Let us break this down. This approach is similar to the third example we just finished now. We know we can't work it this way. We need to make sure everything is in square format. Now we have 2 times 2 is 4. So this is not the square we need. We have 8 here. This is not all we need. But when we look at 2 and 8, they have something in common. 2 of them have something in common. So whatever they have in common, we put it outside or we divide it by what they have in common. 2 can go in 8. So let's put 2 outside. If we do 2 goes here 1, 2 goes here 1, 2 goes here 1, 2 goes here what? 4. So on this side we are left with p squared, and on this side we are left with what? Minus 4 bracket p plus q squared. So now let's solve this a little. We have our p squared minus this 4 can be broken down into 2 square. Are you with me? Then we have p plus q squared. I'm sure you remember bracket p plus q squared is what? Is a perfect square. That means we are going to repeat this value twice. Are you with me? If we have bracket p plus q squared, it means we are going to repeat this value twice. Are you with me? Let's keep going. From this point now, we are going to expand our brackets. We are going to pick all of them one by one. So we are going to have p. So if we pick 1p, we are left with 1p. So we put the p here. Are you with me? Then, 2 raised to power 2 is 2 times 2. So we have 2 2's here. So we put 1 2 here. We put another 2 here. Are you with me? We are going to repeat this twice. So we are going to have bracket p plus q. Why are we repeating it twice without changing their sign? Because their power is outside. When we have the power outside, we are not going to change the sign of what is here. Are you with me? So I'm going to have my p plus q. What are we going to do? We are going to introduce different signs. If this one is negative, this one will be what? Positive. I'm trying to explain it so that we are all on the same page. Remember, we still have our 2 hanging here. We'll come to that later. Now let's open what is here. We have our P, right? Minus 2 times P is going to give me minus 2P. Minus 2 times plus Q. What will it give me? It's going to give me minus 2Q, right? It's going to give me minus 2Q. So I close that bracket. Let me come to my second bracket. I'm going to have P. Plus 2 times P is going to give me plus 2P. Plus 2 times plus Q is going to give me plus 2Q, right? Now, P minus 2P will give me minus P minus 2Q. Are you with me? Plus P plus 2P will give me what? 3P plus 2Q. Then my 2 that is outside, I bring it. So this will be the what? The solution to the question that was given. Let me quickly go over this again. We are given this question, this particular question. The question 2P squared minus 8 bracket P plus Q, everything in bracket. We cannot solve it this way. So to make sure it's in the format that we can solve, we need to divide through by 2. We need to divide through by 2. When we divide through by 2, we are going to keep the 2 outside. Because when we divide 2 by 2, it's going to be 1. That's why we have P squared, because we can't have 1P. Now, when we divide here by 2, it gives us 4. That's how we arrive at 4. Then because we have this, the power to be outside the bracket, we are going to repeat it twice. Now, when we arrive here, what do we do here? We have our P squared minus 2 raised to power of 2. 2 raised to power of 2 is the same thing as 4. Then we put our equation in this format. At this point, what do we need to do? We apply the formula of difference of 2 square, which is A minus B, A plus B. Do you understand? So we have to break this equation, everything here, everything we have here, we have to break it into this formula for calculating difference of 2 square. So that's how we arrived at this. And what do? We have 2P here. We open a bracket. Sorry, we open 2 brackets. Because we have 2P, we put 1P here. We put another P here. We have 2 2's here. We put 1 2 here. We put another 2 here. Then this one, we have to repeat it twice because the power is outside the bracket. So we repeat it here. We repeat it here. Then we open the bracket. After we open the bracket, we have our P. Minus 2 times P is going to give us minus 2P. Minus 2 times plus Q is going to give us minus 2Q. Then on the second bracket here, we have P. We open the bracket. 2 times P is going to give us what? We are using plus 2 to multiply the P. So it gives us plus 2P. Plus 2 times plus Q. It gives us plus 2Q. So P plus 2P gives us 3P. Then we have our 2Q. Whereas here, we have minus 2P plus P. It gives us minus P minus 2Q. Then our 2. That's how we arrive at this solution. So this is the solution to the question above. This is the solution to this question. I hope that is informative enough. Give it a try. From your end, you will see that you will arrive at the same answer. So let's look at the next example. We are looking at example 5. Factorize 45ab squared minus 20a raised to power 3. This is the question. So how do we factorize this question? Solution. We have 45ab squared minus 20a raised to power of 3. When we look at this, they are not in perfect square. They are not what? They are not in perfect square. So we can't solve it this way. We can't apply the formula of perfect square nor difference of 2 squares. What should we do? We are going to look for a common factor between these two values and use it to divide through. So whatever we use to divide this equation, we are going to put it outside the bracket. Let's see what we can do. 45, 20. What is a common factor between them? We can see that 5 will surely go in 45 and 5 will go in what? In 20. A is here, A is here. So 5A, 5a is a common factor between these two equations. So let's divide this equation by 5a and let's see what we are going to get. 5 goes here 1, 5 goes in 45, 9. Here goes here 1, a goes here 1. So we are left with 9b squared minus, let's solve this side. Here goes here 1. This is a in 3 places. So if 1a goes, we'll be left with what? We'll be left with 2a's. This is what I mean. A times a times a is the same thing as a raised to the power of 3. So if 1a goes here, we are left with a times a, which is what? A squared. Now 5 goes here 1, 5 goes here 4. We are left with 4a. Remember, we divide through by 5a, therefore 5a will be outside. 5a will be where? Outside. Are we together? Now let's do it properly. We are left with 5a, 9b squared minus 4a squared. 5a into bracket 9b squared minus 4a squared. We can break 9 down into 3 raised to the power of 2 b squared minus 4. We can break it down to 2 raised to the power of 2 a squared, right? At this point, we can do difference of 2 squared, which is a minus b, and a plus b. Are we together? So how do we do that? Let's do 2 brackets. Bracket 1, bracket 2. We have 2 3's, 2 b's, 2 2's, and 2 a's. So let's put our first 3b, we put it here. The second part of 3b, we put it here. Now we have 2 2's and 2 a's. Let's put one 2a here and another 2a here. Then, difference of 2 square, our sign, we have negative positive. Remember, we still have our 5a outside, right? So this is the solution to this question above. This is the solution to question of example 5, which is what? Factorization of 45 ab squared minus 20 a raised to the power of 3. So the solution to this question is this. If we expand this solution, it's going to give us this. If we try to expand this solution, we arrive at this. So that shows our answer is correct. Let's look at example 6. Factorize square root of 81 x raised to the power of 4 minus 9 raised to the power of 4. If we are given this kind of equation, so how do we solve this equation? If we're given this kind of equation, how do we solve this equation? This equation is a bit different from what we've been solving, but let's give it a try. Solution. If we have 81 and x raised to the power of 4, let's break this thing down a little before we bring in the other part. What is 81? 81 is what? 9 raised to the power of 2, then x raised to the power of 4, all under a square root. Square roots, in my earlier explanation, I explained that square roots means a power of half. Square root means what? A power of half. Therefore, if we have 9 raised to the power of 2 and we multiply it by half, what are we going to get? This half will knock off this 2. We'll be left with what? With 9. Now, if we pick the x raised to the power of 4 and we multiply it by half, this 2 goes here 1, 2 goes in 4, 2. So the x power will reduce to x raised to the power of 2. So we be left with 9x raised to the power of 2. Let me explain this in a way you will understand. We have square root of 9 raised to the power of 2, x raised to the power of 4. Let's do it this way. Since we know that this square root means power of half, let's do 9 raised to the power of 2 multiplied by 1 over 2. And x raised to the power of 4 multiplied by 1 over 2. So 2 goes here 1, 2 goes here 1. 2 goes here 1, 2 goes here 2. So we are left with what? With 9x raised to the power of 2. Is that understood? Now, let's clear the board and continue with solving this problem. So what we are going to get here is 9x raised to the power of 2. So let's bring down this other part to join this equation. So we have minus 9 over 4. Let's make this equation simple. Let's break it down a little. 9 is the same thing as 3 raised to power 2. So 3 times 3 will give us 9, and x raised to power of 2 according to the earlier explanation. 9 is the same thing as 3 raised to power of 2, right? Then 4 is the same thing as 2 raised to power of what? Of 2. So at this point, what are we going to do? We are going to introduce our difference of 2 square, which is a minus b in bracket a plus b in bracket. So at this point, what are we going to do? We are going to open 2 brackets and bring all this value in one by one. We have 3, we have it 2 times. So let's put 1 here and put 1 here. We have x 2 times. Let's put x here and x here. We have 3 over 2 times. So we do 3 over 2, 3 over 2. So when we do this, we introduce different signs. So if we have negative on one side, we have positive on the other side. Now from here, what are we going to do? We have combination of whole number and fraction. So what are we going to do here? We pick 2 as our denominator. Can 1 go into? Yes, how many times? 2. So 2 times 3x will give us 6x minus 2 goes into 1 times 3. We have 3. So we put this in brackets. Let's do the same on this side. 2 as a denominator. 1 goes into is what? 2. 2 times 3x, that's 6x, plus 2 goes into 1 times 3, 3, right? So at this point, what are we going to do next? We look for what is common here in this bracket and what is common in this bracket. So we put it outside. What's common here? 3 is common to the numerator. So we put the 3 outside. Then our 2, 3 over 2. If we take out 3 from this side of the equation, if we take out 3, what are we left with? We are left with 2x minus 1, right? And here, let's do the same thing. Let's take out 3 from the numerator. We have 3 over 2. What are we having left here? We have 2x plus 1. If we open this bracket, we are going to have what is here. If we open this bracket, we are going to have what is here. So we are on the right track. Now, what are we going to do? At this point, what are we going to do? We are going to bring this equation together. We are going to multiply this equation. So 3 times 3 is going to give me 9. 2 times 2 is going to give me 4. So I'm having 9 over 4, 2x minus 1 in bracket, 2x plus 1 in bracket. So this is the answer to the question we have up here. This is the answer to this equation. I'm sure when you listen to the class maybe 1 or twice over, you will understand the class better. Let's look at example 7. Factorize 3 whole number 6 over 25 x squared minus 9 over 16 y squared. This is a bit different from what we've been doing, but you know what? We are going to solve the problem. We are going to what? We are going to solve this problem together. So what do? Solution. We have proper fraction and improper fraction. So let's make the whole thing to be normal fraction. How are we going to do it? Let's solve it one by one. We have 3 whole number 6 over 25. Let's first solve this. We have 3 whole number 6 over 25 x squared. Let's first solve this. 25 times 3 is what? 75, right? 75 plus 6 is going to be 81 over 25 x squared minus 9 over 16 y squared. Let's break this equation down a little. 9 times 9 will give us 81. So we have 9 squared over 5 times 5 is 25. So we have 5 squared, right? X squared. 9 is the same thing as 3 over 2. 16 is the same thing as 4 over 2 y squared. At this point, what are we going to do? We are going to introduce difference of 2 squared. You remember our formula. Now, when we look at this equation, it's so easy to take it from here. We have 2 9s, we have 2 5s, we have 2x. So let's open 2 brackets. We have two 9s, we have two 5s, we have two x. So let's pick one. We have 1 9 over 5x. We have 1 9 over 5x. On the second side, we have two 3s, two 4s, and two y's. So let's pick one. 3 over 4y, 3 over 4y. Let's introduce our sign. So if this side is negative, this side will be what? Positive. Are we together? So let's take it a step further. So what are we going to do from here? So what can we do to this first side of the bracket? This is bracket 1, bracket 2. Let's solve the first bracket first. We have our denominator to be 5 and 4. Let's use a new denominator, which is 20. 5 will go in 20 and 4 can go in 20. So at this point, we want to make this first bracket to have a common denominator. We want the first bracket to have a common denominator. So what do? We use 20 as our new denominator. So 5 can go in 20 and 4 can go in 20. So 5 goes in 20, that is 4. 4 times 9 is 36x, right? 4 goes in 20, that is 5. 5 times 3 is 15 minus 15y. Is that understood? We close this bracket. We do the same thing. Common denominator 20. 5 goes in 24. 4 times 9, 36. 36 what? X. This time around we have plus. 4 goes in 25. 5 times 3, we have 15. And we have 15 what? 15y. At this point in time, let's look for what is common in this bracket. What is a common value in this bracket? If we look at 36 and 15, their common factor is what? 3, right? So let's put another bracket outside. Their common factor is what? 3. If we take out 3 from here, this is 36 divided by 3. 3 goes here 1, 3 goes here 12. So we are left with 12x, right? Minus 15 over 3. 3 goes here 1, 3 goes here 5. So we are left with minus 5y. This 20 is common to both x and y. So if we put it outside, we won't have any denominator again. Now let's go to the second bracket. What is a common factor here? Is 3 as well. So if we do that, so we have 36 divided by 3. 3 goes here 1, 3 goes here 12. So we have 12x plus 15 divided by 3. 3 goes here 1, 3 goes here 5. So we have 12x plus 5y. Remember, this 20, the denominator, is common to both. So we put it outside. Now the last thing we are going to do is we are going to multiply these two brackets together. So if we do that, we are going to have 3 times 3, which is 9. 20 times 20, 400. Into bracket 12x minus 5y. 12x plus 5y. So this is the answer to this question. This is the answer to the question above. Let me quickly run us through this question again. We have proper and improper fraction given as our equation. So the first thing we did is to solve it one after the other. We have 3 whole number, 6 over 25 x squared. So what do? 25 times 3, which is 75, plus 6, 81. 81 over 25 x squared. 81 over 25 x squared. I brought this remaining part of the equation to join this side. So what I have here is what I have here. So nothing changed. So after bringing these two equations together, this and this, after bringing this equation together, I make all the values in this equation to be perfect square by doing 9 raised to power 2, which is 81, 5 raised to power 2, which is the 25, 3 raised to power 2, which is 9, and 4 raised to power 2, which is 16. So we arrive at this. At this junction, what do? We introduce our formula for difference of 2 square, which is bracket a minus b, a plus b. So at this point, we broke the equation into the negative and the positive side. So we have 2 9s, 2 5s, 2x. So we put 1 9 over 5x in one side of the bracket and put the remaining 9 over 5x on the other side. On this side again, we introduce the 3 squared over 4 squared y squared. We broke it into two. We have 3 over 4y, 3 over 4y. We bring it into the second part. Then we introduce our sign, difference of 2 square. You understand? So at this point, we brought this x value and y value under a common denominator. And the common denominator is 20. So 5 goes in 20 is 4. 4 times 9 will give me 36. 36 what? 36x. 4 goes in 25. 5 times 3 is 15. 15 what? 15y. Remember, we have negative sign, so we brought it down. Then we did the same. On the second side of the equation, we had a common denominator, which is 20. So 5 goes in 20. 4. 4 times 9, 36. 36 what? 36x. 4 goes in 20. 5. 5 times 3, 15. 15 what? 15y. Remember, we have our plus. We brought it down. Now, we decided to sort out what is common between 36x and minus 15y. The common factor is 3. We put it outside. Remember that the denominator, which is 20, is common to both 36x and minus 15y. So that's why we decided to put it outside with 3. So we have 3 over 20 and we have our equation simplified. You understand? Then we did the same thing. We brought out the 3 over 20. When you look at this equation, what we have here and what we have here, it shows what? It shows our formula for difference of 2 squared, which is a minus b and a plus b. So at the final stage, what do? We multiply everything outside the brackets and we arrive at 9 over 400. 3 times 3 is 9. 20 times 20 is 400. Then we bring our brackets together. Are you with me? So this is how we arrive at the solution to the question given. We've walked through different examples. We've walked through different scenarios of difference of 2 squares. Now let's see how to solve problem of perfect square. Let's solve some problems of perfect square. Now look at the example 1. So what are we given? We are given factorize y squared plus 14y plus 49. So how do we solve this kind of problem? I'm going to solve it in 2 different ways. But first, solution. I'm going to use this first method to solve it to achieve a point. So remember, when we have the value of our a to equals to 1, what do? We look for 2 values that when added will give us plus 14. When multiplied will give us 49. And you know, the answer that readily comes to mind is what? It's just 7. 7 times 7. 7 times 7 will give us 49. 7 plus 7 will give us 14. So let's introduce our 7 right away. We have y squared plus 7y plus 49. At this point, what do? We just group. What's the common factor in the first bracket is y, right? We put our y outside. We are left with y plus 7. Then what's the common factor in the second bracket is what? It's plus 7. So if we take out plus 7 from here, what do we have? Y plus 7. You know, if we have 49 divided by 7, 7 goes there 1, 7 goes there 7. Now, when we have our 2 brackets and we have some values outside, what do we do to the value outside? We bring them together. Y plus 7. We have the same value in the first bracket, the same value in the second bracket. So what do? We just pick one. So we have y plus 7. So this is the answer. But when you look at this answer, we have the same thing in the first bracket and second bracket. So if we look at it, we have the same value in the first bracket and the second bracket. So we just write our answer as bracket y plus 7 squared. Now, remember the formula we are given that if we are to expand this equation of a perfect square, if we are expanding perfect square, what is the formula? This is our first term, y. This is our second term, 7. So the formula is square first term. If we square first term, what's our first term? Y. Then plus, because we have plus here, we are doing plus twice the product of first term and the second term. Twice, what's the product of first term and second term? That's 7y. Twice the product of first term and second term. Plus what? Plus square of second term. That is 7 squared. Now let's resolve what we have here. We have y squared 2 times 7y. That will give me plus 14y. Plus, what is the square of 7? 49. Compare what we have here and what we have here. Is it the same? Good. If that is the same, so anytime we look at an equation and we see that is a perfect square, if we are to solve the problem of perfect square, we notice that this is our first term, perfect square, and our second term, perfect square. What we are going to do is, since we have plus here, we have y squared, we open two brackets, y squared. Then what is the square root of this? The square root of this is 7. So we just do 7. Remember, we have plus, so we just put plus, plus. This is a short method of solving perfect square. Whenever we look at it and we see that this is perfect square, we just look for first term and second term, and we what? And we produce them twice. My first term is y. Let us unsquare it. My first term is y. My second term is 7. So we just do it twice, and that's it. Now let's look at example 2. Example 2. Example 2 is factorize 9x squared minus 24x plus 16. So look at this equation. Solution: 9x squared and 16. Do they look like perfect square? Now, what is the perfect square of this? If we have 9x squared, can we break it down? If we do that, we are going to have 3 squared x squared, right? So we are going to have this as 3x squared, right? Now, if we have 16, it's going to be 4 squared. Let's break this into two different brackets. 3x, 3x. But look at the sign. Is what is negative. So before we put our 4, let's know that we are having negative. So this will be the solution. Are you with me? Let me walk you through this equation. If you remember, when we have a plus b and we expand this equation, we had a squared plus 2ab plus what? B squared, right? This is our first term here. This is our second term here. Now, that's what I did. I picked the first term, I break it down into perfect square, which give me this. Then I pick the second term, break it down into perfect squared, which is this. Now, because we have minus, whenever we are breaking it into two brackets, we need to consider the minus. So this is 3x twice. I put the first 3x in the first bracket and the second 3x in the second bracket. Then this 4 squared, one is put in the first bracket and the second is put in the second bracket. Then we introduce our negative sign. Do you understand? Now, to be sure that our equation is correct, let us expand this bracket and see if we are going to arrive at our question. 3x times 3x, that will give me 9x squared. 3x times minus 4, what would that give me? It's going to give me minus 12x, right? Minus 4 times 3x is going to give me minus 12x. Minus 4 times minus 4 is going to give me plus 16. We have 9x squared minus 12x plus minus 12x will give me minus 24x. Then my plus 16. Let's check the equation we are given up. What is it? 9x squared minus 24 plus 16. And we have 9x squared minus 24 plus 16. So this our equation is right. We are correct. We could go the other way around by doing what are the values that will replace our minus 24. Then we get the value and substitute it. When we work it all the way, we are going to come down to this value. We are going to come down to this value. So we can go that route of looking for the value of b. when we do our A times C, we have our AC, then we look for our B, and we work it the way we've been working our factorization equation when the value of A is greater than 1. But to save time, we can go this route. This route is easier and straight to the point and can be used in the exam situation. So we are done with this. Let's look at another example. Let's look at example 3. Example 3 is factorize 1 plus 4 raised to the power of x plus 4 over what? Over x squared. This is what we are given. So what is our solution? We have our first term and we have our second term. And what do? 1 squared is the same thing as 1. 4 over x squared is the same thing as 2 squared over x squared, right? Now, at this point, what are we going to do? Let's open our two brackets. If we open our two brackets, let's put 1 here and 1 here. Since 1 raised to the power of 2 is 1. Remember, here we have 2 over x in brackets, right? So we are going to have our 2 over x here, 2 over x here. And when we look at this sign, it shows it's positive. So we put positive, positive. This is our answer. This is our answer, and it can be written as bracket 1 plus 2 over x squared. So this is our answer. So this is straightforward and very easy to work with. Even in an exam situation, if you can explain what you've done, you are going to get your full mark. So I see this as a faster means of arriving at your answer. Now let's look at another example before we call it a day. Example 4. What's our example 4? 9 over 16 minus 3 over 2x plus x squared. This is our first term, right? This is our second term, right? Now, what is our solution? Our first term is x squared. Break it down. We have x in two places, x times x, right? So our second term, what do we have? We have 9 over 16, which equals to 3 squared over 4 squared, which gives us 3 over 4, bracket 3 over 4 squared. Now, at this point, what are we going to do? Let's open our two brackets. We have x in two places. Let's put one x here, another x here. What sign do we have here? It's minus, right? So we drop our minus, then we pick 1. Since this is 3 over 4 is in two places, we have 3 over 4, 3 over 4. This is our answer, straightforward, or we can do it this way, x minus 3 over 4. So that's our answer. Thank you for waiting to the end of the class. I won't take your presence in today's class for granted. So I hope this class is informative enough, and I want to say thank you. The next class will be coming up shortly. Find time to go through these examples. Make sure you understand every part of it and apply the knowledge you've gotten to solve past questions, textbook questions, and every other question. By doing that, you broaden your knowledge, you become better with mathematics, and that's what we want to achieve. So we will see you in the next class. Make sure you've practiced adequately before you come to the next class. Thank you very much. See you in the next class.